along. You have reached Russ Grease with RWG-Research.com. Open-source-energy.
Video series RWG-OSD OverSized Delta. Audio check. Hello. Hey, what's up everybody? My name is Russ, RWGResearch.com, QuantumGravityResearch.org as well. Check it out. So, I'm going to be making some parts in this video for the OverSized Delta RWG. First of all, sorry about the background noise. I'm cutting some plates for the arms as well on this guy, but I'm going to be using this material. I happened to get lucky and find this material after noticing what the external version, or the outside of this material is kind of marble-like. It's very different. So I had some of this plastic, didn't know what it was. Went to looking, found this, and I was like, that's what I want. Because it's really hard, but yet it's a type of nylon, so it's perfect for wheels and things, which is what I'm going to be making. So I'm going to be making wheels for this type of aluminum extrusion, and this is 80/20, by the way. This is what I built my newer OverSized Delta printer out of. And I've got these bearings out of hard drive. These are actually the reed head hard drive bearings. I showed this stuff in a later video, an earlier video, if you want to check that out. But basically I need this to fit inside of this, and then have grooves on the outside of this to fit the channels in here. So that's what we're going to do in this video using the lathe. Let's get started. Alright, so we're going to be using some tooling. This is all high-speed steel. I don't know if it's what's preferred for cutting nylon. I made this in another video. Again, if you want to watch it, go check it out. I'm going to be using a cutoff tool. This is a very thin cutoff tool. And then I'm going to be also briefly grinding this down and making a boring tool, custom boring tool. We're going to try to get all that on this one head so that I can just flip it around and make all my cuts. One piece, one piece, one piece. I don't know how well that's going to work as far as tolerance, but we're going to try it and see what happens. So let's get that set up. Alright, so here we are. We are at the lathe. Basically, we're going to put the tool in there, get everything set up. This is the boring bar. I didn't take great pictures of this. I'll see if I can get some. And basically, we're going to just set it up in here, tighten it down, and test a piece and make sure it cuts well, because I did grind this on the grinder just as I made that other tool, same method, and make a few passes testing and see what we got. Alright, after we was satisfied, I then grabbed a drill bit of the appropriate size, a little bit smaller than what my bearings are, and I also grabbed a piece of plastic that I showed in the last video that I liked, and this is actually what I ended up buying. So I took that, drilled it out, then I bored it out, and I test fit it and just make sure it was going to work well. I then inserted the actual plastic I'm going to be using. I then put the tool, the other tool that's supposed to be cutting grooves, I put it on the other side of that lathe tool holder, and then cut the edge, trimmed it, make sure it's the right height. Alright, so after I got that other tool in there, what I ended up doing is finding that little bitty groove that I cut in there originally in that other video. That was my marking. That was sort of my depth marking. I wanted to sort of make sure I didn't go past that. So, or at the end should have been right out that anyway. So I marked it with a marker. And one reason I'm doing this is because you got to remember I'm going to be unchucking the plastic and then rechucking the plastic every single time. So I need a mark to reference the zero for my tool. So I took the calipers, marked it just as I showed in that last video. The marker there was just my dye, my ink that I don't actually have on hand. So this gave me my reference point. Alright, so let's talk about why and what I've got set up here. So originally I was going to use that cutoff tool, but I didn't. I ended up not using it because I did not want to move the head around, like spin it around. I wanted everything to be identical. So I got everything set up so that it's square, the tool is square, everything's square with the plastic. And then basically that boring section that you see on the front is going to be stationary, and the wheel cutting, the actual channel, the profile I should say, that profile cutter it will be chucked in the other side of the tool holder and it will not move. Neither one of these two will move, and I will set the references at whatever I feel like on the indicator, because I do have a number dial visual indicator on telling me where I'm at. I actually installed those on this and that milling machine that you saw. So the same thing you saw in the other video with the numbers on it, that's the display. That basically is on this machine as well. And so it doesn't really matter where it's at. Could be at 100, could be at 5, could be at 10, doesn't matter. I'm referencing that always as I make these cuts. So basically I'm making the inside cut, the outside cut, referencing whatever number that is, and then I don't have to worry about it being off. Every one of these will be identical because I'm referencing where the actual point is. So let's watch one of these in real time. Basically this is the very first cut, and all I was doing here is just trying to get a reference for the actual speeds that I need to be cutting this stuff at. So the stuff is a type of nylon. It does sort of melt quickly, and so you have to sort of cut it at a slow speed. So that's actually what I'm doing here, is just testing speeds, trying to find out what the best is for this particular plastic. So after that, I decided it was just a little too fast. I went ahead and slowed it down a little bit, changed the gear settings, slowed it down. I believe my final speed was like 260 RPM, I believe it was. And then I went ahead and checked it again, made sure everything seemed happy. And then I actually decided to run the tool in and then like right back out to sort of check. If you let the tool sit against there, it sort of gets hot and gets gummy, and it doesn't leave a clean cut when you pull the cutter away. So I had to sort of test at what speeds I needed to come in, cut, and remove in order to get a nice smooth round with no little lip or edge or something like this. Because if you did let it stay in there for a while, it would melt and completely ruin what you were trying to do. And on to the next step. So here I'm using what they call a center drill. This is a special drill bit designed to actually drill in the center. A regular drill bit will actually walk. This particular drill bit is designed not to walk and to create a perfectly centered hole. You always use this on turning operations to get your hole started. You should usually use this on a milling machine or even a drill press to get your hole started in the right spot. Otherwise the bit could potentially actually work its way off and not be in center, and then it's not in the center of your hole, etc., etc. So the next step is to use the regular drill bit. I don't even remember what size this is, but it's a little bit smaller than my bearings because I want to ream out the center with the actual reamer, or the boring bar, excuse me. So basically we're going to cut this out with the actual drill bit. Now I decided that I wanted to try cutting the outside first, then the inside, and so in this particular version here I did the outside first and then drilled the inside. That way when I was cutting the outside it didn't want to bend or shift at all, it didn't have anywhere to go, it was fairly solid. So drilling second was seemed to work okay in this process. Next step is to bring the boring bar tool into position. Again, I was reading the indicators telling me exactly where I tested at to make sure it never was in the wrong spot. So just run this guy in, and this again the drill bit was so close that I just barely had to take off an edge with the boring bar here, and no big deal, it seemed to work pretty smooth. I found out that certain times it didn't want to work well. I had to go faster or slower depending on how the plastic wanted to cut, and of course the thing was running in reverse when you're cutting the boring bar because it's actually cutting the backside. So then I test fit it with the bearing, just confirmed that it was in the right spot. I then proceeded to run it through again, and I kept doing this until I got the bearing to fit just where I wanted it, because the test earlier was just a test. This is the final piece, and so it has to be correct. So I just kept doing this, kept test fitting it until it just almost had to press fit it into the plastic. I didn't want it to slip fit, I wanted it to be slightly press fit. Alright, so you can see here, I put it in there, fit just perfect. I could sort of wiggle it in, felt really nice and snug. Once I was satisfied, I set the digital indicator to 0, so I basically knew exactly where the cut needed to be, so I could really only make one cut on the next round instead of making many cuts to get it just right. The next thing we did was something that I was always told not to do, and I did it anyway. And the thing you're not supposed to do is use hand tools or knives or saws or anything on the turning. It's not a smart thing to do because you can get your hands in there. I was out of tool holders, so I decided to grab my pocket knife, and while it was rotating, cut the plastic with the razor blade until it became thin enough and it fell off. Now, later you'll see why this is a bad idea, and you should probably listen to the people who teach you. So I'm teaching you right now. Don't do it. Find another method. Alright, so I'm going to show you the rhythm really fast. Time lapse of many cuts here, many actual pieces. So basically drill, ream, I guess I should say bore, not ream, bore, and then cut the tool, the actual profile, and then cut it off flush with the end. Just butter it up with that same tool because the corner is sharp. And then I use a tool here to clean up the inside, which I will show you what it is in another video, but basically it's called a deburring tool. It works really well. It's basically a very sharp edge, sort of like the edge of a razor blade if you were to run it sideways, but instead of running it sideways, it's got a nice little rotating thing on it, and it's got an angle on it, and it sort of matches it. It works really well. Again, you're not really supposed to use hand tools while the lathe is spinning though, but you can use this tool static, and I will show you more of what that's all about in a later video in this series. So I had a few complications while I was doing this. One of them was that the boring tool that I created wasn't long enough, and I could only get a single set screw on the top there on the tool holder. I could only get one set screw on there, and so what was happening is over a period of time it was actually moving. So I had to move tiny little bits, and I just kept checking and checking and checking because I noticed it was moving. So what I did towards the end there is just keep checking until I got the thing right, and basically it was moving in the direction that was too small, so it was easy just to constantly check. So that worked out okay, but normally if the tool was longer, this would have been a little easier. Things would have been exact every time. After a while, I decided to make a little mark using a Sharpie on the boring bar to give me an actual depth measurement. I could do the exact same thing on the drill bit. I could use the digital readout, but don't forget, I had to move the plastic every time, so that completely throws off that actual reference on the digital indicator. So doing it manually with a little marker. Now let's get back to that thing I told you about earlier. Shouldn't use hand tools and things like this. So I was taught not to do this because you could potentially get your hand in the chuck, and well, that's spinning pretty fast, and it's a big giant chuck of metal, and your skin is just skin, so it's not anything against that steel, especially spinning at this RPM. And if you watch closely, the knife I was using as a cutoff tool went in at the last moment, went in too far because it cut it off, and I was putting too much pressure, and the chuck barely nipped my finger. It hit me 3 times, one on the end of my finger, one in the middle, and one up towards my knuckle. And it took some skin off, so a little bandage and some blood in the rest of this video. Sorry about that, but it's a good lesson learned. It's a good recorded lesson learned for myself later. Just work smart, listen to what you've been told. Don't leave the chuck in there. Don't leave the things in the wrong places. You got the power on, you're changing tool stuff out, just turn the power off, E-stop. Do what you're told. It's quite important. Alright, so I'm going to show you how fast you can make one of these interesting looking pieces. It's an interesting profile to be cutting this fast, so I'm going to let you watch this in real time. This is the importance of getting all your tools set up. your measurements just right, then you can just rip these out. It takes a lot less time than you would imagine it would if you know how to do it right. So let's watch this in real time so you can hear the wonderful sounds of the lathe. Now, as you can see here, I got a little smarter. I only cut a channel into the plastic and then finished it with my knife. So you can see how relatively fast this can be if you've got everything set up right. It's not as complex or difficult as you may think it could be, if you know how to do it. Oh, I bet some of you were thinking, how are you going to clean up the other side? Well, I went back, chucked each piece in the lathe, used my deburring tool. It's not in the handle, I'm just using it, holding it by hand. It seems to work okay. And just deburred the edge of it. Must be so cautious here because a little slip. No pressure really on this, just barely touching it to get it to trim that plastic, but if you slip, yeah, bloody knuckles. And then, all of them. Just boom, 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 boom. Get her dead. Alright, so here's a little close-up for you. You can see some of the small little ripples in there. That's due to the deburring tool kind of bouncing around. So now the time to put those bearings in. Yep, we gotta drill holes first. So, I set up the milling machine, used a couple of magnets on one of the parallels, attached it to the end. That gave me something to rest these things against. And then using a drill, just drilled the holes in there right in the center, and that's allowing my set screw to be put right in the right spot. Now you may have noticed I didn't use a centering drill first, like I told you you should. I wasn't too concerned about this because I was going to oversize them anyway, so you should have used it there, but I didn't. Alright, next step was to make a hole a little bit deeper in that original one. The original hole I drilled was just for the small screw to go through, and it was oversized, so that's why I wasn't concerned about being centered. And then this one, this is actually a drill bit. I'm just using the drill bit, slowly digging into the plastic and then pulling it out. I was really afraid of doing this in the drill press because I didn't want to get snagged and get sucked in, and it went too far, and I don't have very good precision on the Z-axis on that milling machine. So you can see how I've just sort of cut a little taper in there. Worked out pretty good. And finally, the last step. Take the bearings, put them in there. So here's what I did. I took a piece of, I took a what I call parallel channel locks. So the channel locks actually move in parallel. It's almost like a vise or clamp or something that moves in parallel. And took the bearings and then took a washer, put put it over top of the part of the bearing that was the actual inner race. Well, I should say it was actually the outer race, so that I could push against the outer race and push it basically into the plastic wheel. So what you got to remember here is that when you're pushing bearings into things, if you push the center race at an angle like I'm doing, then you're basically going to either ruin the bearing, or it's going to have a bad spot or a little niche in there, because you can damage the bearings this way. So anytime you press bearings, you always want to press whatever part of the bearing you're pressing onto whatever it is you're doing. You should always use something to sit against the inner or outer race, depending on how you're pushing it. So I actually tested one in the beginning, and it completely messed up the bearing. So then that's when I did it the way it's supposed to be done. But I did try it the other way. It don't work, especially with these small bearings. They're sort of delicate. So got them all put together, and this is what they look like. Just beautiful. You can see there I broke off the screw on the one. Yeah, that's great. But you can see there that one's good. So worked out fine. Alright, well that ends this particular video. Now I'm going to give you a little snippet of my wife trying to narrate what I was doing. Enjoy, God bless, have a good day, and we'll see you on the next round. Okay, my wife's going to narrate.
This is a milling machine. I'm rolling it back out and making sure my hands are out of the way. And we're going to stare at it for a while. Keep staring. Oh, there he is. We're going to put our part back in. Make sure it's tight. Turn the knobby thing. Swivel it around. Let's do the other side. And wait longer. Oh, we got to tighten these nuts back down. Nope, I think he's loosening them. Lefty-loosey. Pulling it out. Oh, we're walking away. And wait some more. And he comes back in and says some more words about the part that we can't see that he's holding in his hand. And oh, there he is. We're going to put it back in. Really have no idea what he's doing.
It's a lathe, my dear. Thanks for playing the game.